Our committee member, Dr. Sherwood Rowland, will make the first presentation to Dr. David Keeling.
Carbon dioxide is invisible to the human eye, but readily absorbs some lower energy infrared radiation in a distinctive identifying pattern. These same infrared energies are emitted towards space from the Earth, and their absorption by carbon dioxide in the atmosphere warms the Earth by 57 degrees Fahrenheit, the natural greenhouse effect. The release of carbon dioxide during the burning of coal, gas, and oil should cause it to increase in the atmosphere, but measurements were scattered and inconsistent. In 1958, C. David Keeling placed a greatly improved instrument of his design on Mauna Loa in Hawaii and another at the South Pole, and began a series of measurements which continue to this day. In the first several years, he identified the summertime decrease in carbon dioxide associated with its photosynthesis into green plants. Then, as the measurements continued, it became apparent that the yearly average was steadily rising, and the 315 parts per million of 1958 became the 380 parts per million of carbon dioxide in 2005. This is the great, indisputable bulwark of our concern about global warming and the driving force for our changing climate. I'll ask David Keeling to come forward and receive the 2005 Tyler Prize for Environmental Achievement.
I've been really overwhelmed by this coming together tonight to find so many people that I have seen in the past but never collected in this way. And I understand now what a community of scientists and people that are interested in the environment are holding this thing together. When I wrote this thing, I was sitting in my home just pondering how I'm going to put something together. And I have some trepidation about how it connects with what I see in front of me now. But if you bear with me, I will unburden some of my thoughts about what's happened over my career. I'm deeply grateful for the honor bestowed by the prestigious Tyler Prize for Environmental Achievement and for being chosen together with Dr. Lonnie Thompson. I say this with great sincerity because I feel very proud that I could be associated with somebody like that's done the work that he has done. The honor should also reflect on those who have worked in my laboratory at the Scripps Institution of Oceanography, several for almost their entire careers. It also should extend to colleagues elsewhere and employees of government agencies, especially the United States National Oceanographic and Atmospheric Administration and its predecessor agencies that go all the way back to the Weather Service, or the Weather Bureau as it was called, which have helped my program over nearly half a century. Some people wonder why I want to make that statement about NOAA, but they've actually done fantastic things to keep this program going. I began graduate studies in physical chemistry as a student of Malcolm Dole at Northwestern University shortly after World War II. I took notice Professor Dole's career mainly focused on laboratory studies, but he also investigated isotopic composition of the atmosphere. A few years earlier, Vannevar Bush, a scientific leader in the U.S. war effort, argued in a report to the U.S. government that science was an endless frontier that could advance knowledge fundamental to progress in society. I was inspired, as were others at the time, to join in this worthy quest for knowledge for its own sake. I want to say, aside from what I wrote there, that I really took science in that vein because I had some other interests, but I liked the idea of knowledge for its own sake. What I didn't realize was that Vannevar Bush had made a distinction between basic research, which he regarded as simply the quest for knowledge, and applied research, which evidently was not. It was especially basic research which was needed to build a reservoir of knowledge for the betterment of the world. Now, people realized how much the World War II effort of the countries depended on science that had been developed up to that time. But he carried it to a higher level of understanding. And he pointed out that basic research deserved help from government, which hadn't been something that had been much of an issue before the World War II. When I began to measure atmospheric carbon dioxide and carbon in ocean water just 50 years ago this year, my work was praised for showing more precisely than earlier studies how carbon was distributed in nature. When I persisted in making measurements of the same kind, because I found the results interesting as pure knowledge, I was supported by program managers of science, up to a point. This point was reached in 1972, after 17 years of my studies. At this juncture in my career, I was told explicitly that a line needed to be drawn between what part of my work constituted basic research and what part was not basic research because it was routine monitoring. The repetitive measurements of my program, even while I was attempting to improve them, I was told, should be relinquished to a government agency assigned responsibility for such measurements and even for where they should be made. I wasn't forbidden to go on with routine measurements, but I no longer qualified for help from government of the kind urged by Vannevar Bush. Since these measurements and the choices of where to make them were the heart of my program, I didn't accept the argument. And with some degree of struggle, I won a series of temporary reprieves from government, which allowed my program to survive. I'm profoundly grateful to the Tyler Committee and to the nominators of the Tyler Award for honoring my work, which still continues. I hope that this recognition of my work and that of Lonnie Thompson will strengthen the belief that repetitive environmental studies, which include repetitive measurements, can be justified as part of basic quest for knowledge. Now, this is somewhat personal to bring this to, this is the end of my written speech, to bring this to your attention because maybe it's no longer an issue, because the issue now has actually grown to a bigger issue. We're all wondering whether our science is going to continue and whether we can make enough sense out of it so people will appreciate it for what it can do to help us in the world that's coming before us now. Thank you.